Hi, good morning, everyone. So let us start again the class by taking a question from past year papers. Let's try to do this question better first. This is a question which combines statistics and econometrics, and it is a 7 marks question. Right? Try to read the question. Show that correlation coefficient between two variables x and y can be interpreted as the proportion of the total variability of y, which can be accounted with its linear regression on x. माने क्या कह रहा है question? What we want to go ahead and show in this question is basically a relationship between coefficient of correlation, or also called as correlation coefficient, and the coefficient of determination. इन दोनों के बीच में हमें एक relationship दिखाना है. We need to show a relationship between the two. अच्छा. So now, just to help you revise, can you tell me what is coefficient of determination? What is coefficient of determination? It is basically going ahead and it is basically a number between 0 and 1. It is a number between 0 and 1. And ये एकदम ठीक बोल रहा है that it tells how much variation in y is due to variation in x. यही बताता है वो. So coefficient of determination, it explains how much variation in y is due to variation in x. Remember, we are talking about a simple regression model. माने हम जिस regression model का बात कर रहे हैं, that regression model basically just has a single variable which is independent, right? That is why we are talking about small r square also, right? Now, if I ask you what is the formula of small r square, how can you go ahead and find? I'm just helping you revise also simultaneously. How can you go ahead and how can you find small r square? So we have studied various formulas to study small r square. So whenever we have our regression equation, y is equal to, basic form is mx plus b. Many books write this as y is equal to beta 1 plus beta 2 x plus ui. This is the form also that many books go ahead and give, right? So whenever you have this kind of regression, then you should remember that when we talk about our r square, this r square is basically explained variation upon total variation. Explained variation upon total variation, right? But explained variation means अगर आप थोड़ा सा वापस जाओगे तो ये ESS भी था और ये TSS भी था. I'm just helping you revise everything related to small r square. And if you remember, this could have also been written as 1 minus RSS by TSS. So these were the various ways in which we could have gone ahead and we could have written small r square. ESS by TSS, 1 minus RSS by TSS, right? This is what we had gone ahead and we had written. Now, we need to show, so this is the first part. This is coefficient of determination, right? We need to go ahead and we need to show that there is a relationship between this coefficient of determination and the coefficient correlation and correlation coefficient, right? So, second part is correlation coefficient. कोरिलेशन कोएफिशिएंट का एक इंपॉर्टेंट एस्पेक्ट ये है कि अनलाइक दिस इज 0 and 1 बिकॉज इट इज टेलिंग यू कि कितना एक्सप्लेन हम कर सकते हैं y को. सो अनलाइक दिस बीइंग बिटवीन 0 and 1, when we talk about coefficient of correlation, right, it is not between 0 and 1, it is actually between -1 and 1, right? Because this is just telling us how much one variable is affecting the other variable. And that effect between the two variables, how one is affecting the other, it can be negative or it can be positive. So basically, this can be between -1 and 1. Rather than 0 and 1, it can be between -1 and 1, right? And this is telling us how much one variable affects another, and also whether the relationship between them is negative or positive. It also tells whether the relationship is negative or positive. And here further, you can go ahead and you can address that if it is -1, that means it is a perfectly negative correlation. When x increases by 1 unit, y decreases by 1 unit. So this indicates a perfect negative correlation between x and y. There is no independent and no dependent variable here. These are two variables जिनके बीच में हम देख रहे हैं कि वो कैसे एक दूसरे के साथ मूव कर रहे हैं. But here in coefficient of correlation, there is no variable which can be called कि this is independent and this is dependent. Nothing like that happens. Huh? We are just telling whether the relation between them is very strong, moderate, weak or very weak. हम बस ये relation बता रहे हैं. And then you have +1, which is telling you perfect positive correlation between x and y. Perfect positive correlation between x and y. Now, there is a relationship which you should know, that this coefficient of determination, this r square, can be written, it can be written as correlation coefficient whole square. So this is given by r, this is given by r square, right? The interpretation is different if you just saw, but the relationship is that r square, which is coefficient of determination, right? This is equal to correlation coefficient whole square, right? Correlation coefficient whole square. That is a relationship which exists for them, right? Now, if I ask you, okay, fine, what is this, what are the formulas for the two things? And how can we go ahead and how can we say the thing? How can we go ahead and say this thing? Then even through formula, we can go ahead and we can represent the same relationship. We can prove the same relationship, right? But for me, proving was not that important here. For me, it is more important for you to understand that this relationship exists. Here, already this r square itself is called coefficient of determination. And here r is called correlation coefficient. R square को कुछ नहीं बोल रहे हैं वहां पे. R is called correlation coefficient, right? And when you square correlation coefficient, then you go ahead and you get R square of, which has the same value that is of coefficient of determination. Okay. Okay. Now let's focus on correlation coefficient formula. So we can go ahead and we can say that the R between two variable xy can be written as covariance of xy upon the standard deviation of x into the standard deviation of y. Right? This is the formula which can be used. When we talk about covariance of xy, if it is from the sample, it can be written as summation x minus x bar y minus y bar upon n minus 1. Upon n minus 1. Similarly, if I talk about the sample, then this can be written as summation x minus x bar whole square upon n minus 1 under root, and sy can be written as summation y minus y bar whole square upon n minus 1 under root. Right? So if you just plug the values here, you will get summation x minus x bar y minus y bar upon summation x minus x bar whole square summation y minus y bar whole square in the under root. Right? You can also go ahead and you can also write this by one more formula. You can open this up and the value of R, you can also go ahead and get this n summation xy minus summation x summation y upon n summation x square minus summation x whole square, right? N summation y whole square minus summation y whole square and then under root. These are the various formulas of R, X, Y that can be used, right? This is your correlation coefficient formulas. Okay. Now, when you go ahead and when you look at the coefficient of determination formula, I've already given you one form of coefficient of determination. This is this explained variation upon total variation, ESS by TSS. It can also be written as 1 minus RSS by TSS, right? And when you go ahead and when you use this thing, if you look into the books, you will notice that one other formula that they go ahead and they give you is that this R square, this is equal to variance of y hat upon the variance of y. This is also because y hat is what? Y hat is what is being explained. So if I just rewrite this thing, I can go ahead and I can rewrite this thing as y is equal to y hat plus ui. So this is your explained part. This is your total. And this is your unexplained part. Right? And you remember that we were subtracting mean from both sides, right? We were finding the mean, subtracting that equation, and then we were able to derive ESS and TSS. So basically, R square can also be written as variation in y hat upon variation in y. That is another way of going ahead and writing this, right? Now it's very simple. I am leaving this up to you. You just need to go ahead and you just need to open this up. You need to open R square up. When you will open R square up, you will notice that it will come down as square of this thing, right? When you will square this and when you will open this up, you will go ahead and you will get the same answer. And that is what we wanted to go ahead and we wanted to prove, right? So basically, in this question, what is important here is for you to go ahead and you to understand the difference between coefficient of determination and correlation coefficient. And once you understand the difference between the two, then it is equally important for you to go ahead and also to be able to prove that the two formulas come towards the same thing. They give you exactly the same thing. Okay? That is what the question is going ahead and asking. Okay. So now let's go back to what we were studying.